Hey everyone, welcome to another video in this playlist. In this video, we'll be talking about Spark structure streaming checkpoint. This is a very crucial topic in Spark structure streaming. So checkpointing helps you in two major things, right? One is fault tolerance and one is stateful operations. Okay, so let's dig deeper into each of the topic. One is fault tolerance. What happens is if your streaming application crashes or stops unexpectedly, so checkpointing allows Spark to recover and resume processing from where it left off. Without it, data might be lost or reprocessed incorrectly. So yeah, systems are bound to failure no matter how you design. System will fail, your Spark job might crash in between. So you need a mechanism with which your Spark can start reading from where it left off. That's why this Spark checkpointing comes into picture. So we'll be seeing the content of it, how does it do that and all that. Whenever we are doing any stateful operation, right? So stateful operation like aggregation, joins and windowing requires a state to be maintained over time. So this is where the state information is periodically saved into the checkpoint, ensuring it can be restored upon failure. So we have seen that whenever we are using different modes like complete mode or update mode, we are storing all the data into the state store, right? This is where it would be stored in the checkpoint location. So defining checkpoint is very simple. You define the location. It could be right now I'm using a mount location, but it could be any S3 location and whatever it is, and you define as a option of checkpoint, right? You just define. So this is all it needs to just define the checkpoint. Okay, so now let's dig deeper to see what are the contents of this checkpoint location. So I'm using dbutils fsls command. So this is the magic command that Databricks has. So it has different subfolder inside it, right? You have commits, you have metadata, offset, sources, state. So let's see some of those folders. First we'll see the metadata. So this will give you a ID. This is the query ID, or you can say like the query listener ID for this particular job, right? So whenever you're filing any query, it generates the ID. That's what this ID is all about, right? Now let's see the offsets. So offsets will have folder like 0. It can have 0, 1, 2, 3. What are these zeros and ones, right? What happens is whenever you are running any micro batch query, right, it creates different batches. So you get like batch ID 0, 1, 2 like that. So any batch ID, it will come like this, right? You have the offsets and you have a 0. 0 means 0th batch, right? The first batch. So if you have multiple batch, you will have multiple folders here, right? Now what I'm doing, I'm just doing fs.head on that particular 0. I get this type of content here, right? So what I did was I just formatted that as a text here. So this particular thing will have like three content. One is this part, and one is this part, right? So v1 is nothing but this is the version of checkpoint file format. So it might happen that in future this file format may change, right? To have this versioning in place, that's why this v1 is written there, right? So that Spark knows, okay, what type of file format it is for checkpoint location, right? Now you have this second format, that is the JSON object. So this will contain your like what's the batch timestamp, and you have some configuration in place. Some configuration that you might be aware of: shuffle partitions. You have provider class, which is like HDFS backend state store provider. So we are not using RocksDB provider here. So similarly, you have different configuration provided here, right? Now, the most important part is offset and state information that is coming towards the end, right? So let me just explain you that. So what it represents is, it represents your topic, okay? Now this particular portion is like you'll have different partition, right? So this particular topics has like 3 partition. That's why you get like 0, 1 and 2. And this number means for second partition, this is the offset that is already processed, right? and for this partition 742 is processed. So whenever I'm restarting the stream, it will start reading from 708. Similarly for 742, it will start reading for 743, right? So this is a very crucial information to have. So this is how, if any job fails and if you are restarting the job again, it knows that, okay, what's my last batch is 0. How much did I read? I read till this position, right? So I need to start reading from after that particular offset, right? So if you see that partition 2 has been processed up to so this is just an explanation of this, right? So this is all I wanted to share as part of checkpointing. See, internally you don't whenever you're working on any project, you don't have to touch this particular checkpoint location, right? So you do not do any modification for it, but I just wanted to show, like, internally how does it store the data, how does Spark handles any failure. So if you know this particular concept, it will make your concept even clearer, right? I hope this video was helpful. So if you like the video, just give it a like, and if you haven't subscribed to my channel yet, do subscribe. Thank you so much.